I'm Anil Kumar, and in this video we will see how to use sin square theta plus cos square theta equals to 1 to prove some identities. So we'll begin with some very basic identities. So we'll start with, let us say we have sin square x minus cos square x. That is equal to what? We can start with this, and this is actually equals to 2 sin square x minus 1. So we'll prove this identity first, and then we'll also prove what is cos square x minus sin square x. Well, that could be written as 2 cos square x minus 1. So these are the two identities which we are going to prove in this particular video, and we'll apply or we'll use sin square theta plus cos square theta equals to 1, right? So that is an exercise for you. You can pause the video and solve this particular question. Now, to prove identities, you could start from left side or from right side. So that is all up to you. Basically, you need to prove that left side is equal to right side. That is the whole idea. So we will actually follow both strategies and see how we can actually prove this, right? In the first case, what we look into is left side is sin square x minus cos square x. On the right side, I have only sine, right? So that means I can apply this particular identity by replacing what cos square theta is, right? Then I'll have terms only in sine. So that could be one strategy for me, right? So second strategy could be I could replace 1 by sin square theta cos square theta, and then I'll get both the terms. I'm missing cos, right? So I could get both the terms. So that could be my second strategy, right? So either way, it's up to you how to use. Let us apply both ways of doing it. So one, we could write what sin square theta is. Sin square theta is equals to 1 minus cos square theta. From here, we could write cos square theta is equals to 1 minus sin square theta. So this particular identity can be written in three different ways. So we can actually use any one of these to prove the given identities. You get the idea, right? So if in the first case I want only sine, then in that case I need to replace cos. So let us do that. So what we get here is, let's start with left side. So left side is equals to sin square x minus, what is cos square x? Cos square x will be 1 minus sin square x. So in brackets write 1 minus sin square x, correct? Now we can open the bracket. So we get sin square x minus 1 plus sin square x, right? Now these two sin square x combine to give you 2 sin square x minus 1, and that is what the right side is, right? So in 3 steps you can prove this identity following this method, correct? So second identity is very similar to the first one. So in the second identity, what you could do is replace sin square x with 1 minus cos square x and prove it. So that is how it could be done. But here I will show you alternate method. This time we'll begin with the right side, right? So we'll begin with the right side and then prove the identity. So you could go either way. The right side for you is 2 cos square x minus 1. Now instead of 1, I can write sin square x plus cos square x. You get the idea, right? So I replaced 1 with sin square theta plus cos square theta. Since the argument is x, I'm using x, right? So the right side now is 2 cos square x minus sin square x minus cos square x, right? 2 cos square x minus cos square x is cos square x. So we get cos square x minus sin square x. Now that is my left side. So this is equals to left side. So I have proved that right side is equals to left side. So that is how I could prove the second identity. So the idea which I am sharing with you with this video is that you could start from either side and you have a lot of options to work with. Follow the ones which you feel comfortable with. I hope that helps. Thank you and all the best.